A quadratic can be graphed by calculating its vertex. In this lesson, we'll take a look at the vertex formula. The vertex formula can be applied to equations that are in the form y equals ax squared plus bx plus c. So the x squared term needs to be right after the equal sign, then the x term, and lastly the constant. Once your equation is in that format, you can use the vertex formula. Now, before we jump into the formula, I want to state that the vertex is an ordered pair, and frequently the ordered pair is described as HK. H is connected to the x value, and k is connected to the y value of the ordered pair. And the only reason why we use x and y in the equation is that x can be a constant variable and y is a changing dependent variable. Over here we use h and k to state that the vertex will never change. It is going to be a specific value, and h is calculated with this formula. So this is the formula we need. We need h equals negative b over 2a. So let's identify where those letters are. B is the coefficient in front of the x term, and a is the coefficient in front of the x squared term. Notice the c value does not affect this formula. Okay, so let's start with using that, because in step 1 it says calculate h with negative b over 2a. I'm going to take my example, y equals x squared, so there's a silent 1 here, plus 2x, that means that b is a 2, and plus 3 tells us c is 3. I need a and b. So h is going to equal negative b, which is 2, over 2 times a, so 2 times 1. Use the order of operations to simplify this. We get an h value of negative 1. Now we need to find the k value, or the y part of the vertex, and the k value is found with f of h. So this means take that value of h that we just found and plug it into the function or into the equation. Okay, so I'm going to take that value of negative 1 and substitute it in wherever there is an x. K will equal negative 1 squared plus 2 times negative 1 plus 3. Follow the order of operations. And we get a vertex of negative 1, positive 2. So that is our vertex. Now, of course, with a parabola, we need more than one point to be able to graph this. In step number 4 here, it says use the a value to plot 2 more points and draw the parabola. Remember, a parabola is symmetric, and it's symmetric about the vertical axis, or the axis of symmetry. And this axis of symmetry, if you recall, will be x equals, and it's whatever value is in the x part of your vertex. So x equals negative 1 in this case. That's where our parabola is going to be symmetric around. I need 2 more points. The nice thing is this a value is going to tell us if the graph opens up or not. So in this case, a equaled 1, and if a is positive, the graph will open up. And if a is negative, the graph will open down. And the other thing that a does, since a is 1, if I change that into a slope, so I have a value of 1 and I put it into a slope formula or into a fraction, I would have 1 over 1. Okay, now this 1 over 1 will help us from the vertex to go over 1 and up 1. Now I went over 1 because my a value is positive. Now because I know a parabola is symmetric, I know from the vertex I could also go left 1 and up 1. And now I have my parabola. I can graph